Hello and welcome to another tutorial. Today we are trying to write a packet dissector. What is a packet dissector? So let's look at the average Wireshark recording, and we can see that the data that is sent here is actually split up into its parts to display me more information about it that is human readable. This recording in particular is a Wireshark recording between Battlefield 3 client and backend. In particular, this is using the Blaze protocol, and this is not encrypted, so not SSL. If you had SSL, you would have to give Wireshark first the SSL keys so it can decrypt it. And it has data in it, which is currently just displayed raw. And I can follow this stream to see how the packets were exchanged. We can already see data in here that is in clear text, but how it's decoded, that's the question that we answer next. And I would like to have the same ability like I have in the previous fields here in the tree, to just fold down the data and see what's actually inside. So how does the Blaze packet actually work? So I made a little graphic. Essentially, we read a few bytes. It has a header with all kinds of stuff in it, component, command, error code, and so on. Sometimes it has an extra payload field for the size, if it's bigger than 60-bit value. So this could be optional here. And finally use a payload, which is the rest of the packet. So, and the payload itself is just a list of TDFs. I think this is supposed to mean type defined field, which has a tag, which is just 3 bytes long, but contains 4 ASCII chars. We will see in a bit. And then we have the type of the field, could be an integer, could be a string, whatever, and the actual field value. So it would be nice to have a field in Wireshark where I can have the header and can display all its members, and then decode the packet to see what the fields actually contain, what data was sent along. The good thing with this packet style is that it's byte aligned, so I can read most of the stuff in the hex editor already, so that is very useful. So let's take, for example, the first packet here, like this, and just decode it by hand. Given my overview. So it's a bit tricky to read, but let's follow with me. First off, we have the payload size. In this case, I can already see that the header is 12 bytes in size, so the rest should be payload and has a size of E5. So that matches up. The next is the component and the command. I will explain this later. Essentially, you have, or let's explain it now. You have different components like an utility component or authentication component and stuff like this. And each of these components have different commands where you can send data to or from. So these are like remote procedure calls, essentially. Then, if it's a packet from the server, it can also contain an error code. Then we have 8-bit the message type, so is it from client or from server. Then we have the upper half of this byte is the header flags, and the rest, the lower 4 bits, and these together makes the message ID, so this is 20-bit. Still, this ends up byte aligned. Sometimes here could be the extra payload size, but it isn't. And then we have already TDF fields where we know, okay, this is the tag field, which we will have to decode, and the type is 3. I would have to look up what 3 is, but I guess some integer or something like that. and yeah, and so on. Then here's the next tag, which has, I don't know, some integer, I guess. Yeah, I don't know, it's not always visible, but it will end up always on a byte-sized alignment. So strings, for example, are always readable. So this is a, let's say, a simple format to explain how to make a dissector. What we need for this, so obviously we have to tell Wireshark that we want to process any data that belongs to our traffic that is interesting to us, and in this case it's all traffic that goes to or from port 30,001. So we have to tell them, yeah, give me all the packets with these ports, and I will additionally decode all the data that will be sent here. Okay. So this is our first packet, for example. Instead of having just this data display, it should show our own dissector. So in Wireshark, where the program is located, you have a folder called plugins, and inside here the current version number, and inside here you can put your plugins that you want to code in Lua. So I already prepared a folder for the Blaze for Battlefield 3, and I have one for PUBG Lite, which I'm currently working on and where I will copy a lot from. Because yeah, why reinvent the wheel twice? Okay, let's see if I got everything. So where do we start? So obviously we need to put a file here that will contain a dissector for Wireshark to find. So this file currently is empty. So actually I can put this on the left side and put this on the right side. And this is how it works. First off, I will create multiple files here, like here, so I can include them. I will have something like a global, let's say, object that I will pass along to every function, in case I need anything of all the other stuff, like constants and fields and stuff like that. So first off, I need that. Let me create a folder. Source, let's create the base, the global object. So in this case it would be just Blaze, or Blaze BF3, but to be shorthand, let's call it Blaze, and we can already local Blaze acquire source Blaze. So this is just our global object. We will need fields and proto stuff later. Okay, then we have to define a function, or create a function. This is name proto dissector, and it gets passed in a buffer, packet info, and the tree to fill out. Okay, that's pretty much it. We have to fill that out. And finally we get the TCP table, because this is a TCP based protocol. TCP port. Almost. So, and our target port, I wanna have variable. For now it's just 30,001, but maybe I need another port in another recording. Okay. First thing, if we don't have a tree to display, so it's just this function will be called multiple times by Wireshark, and so it has a pre-processing steps and it has a post-processing step, and then every time you click a packet it will call it again. So in the pre-processing step you don't have access to the tree that displays any nodes, so it doesn't you don't need to do anything if the tree isn't even there yet. And these kind of packets don't need pre-processing. That would be, for example, a later packet depends on code from on data from the earlier packets, and so you have to keep track of packets. And so it would be nice to have a pre-processing step to organize all that, and then just a display step where you just display everything. We will make it simple. We first will also process a packet, and every time this function is called, see if you already processed that packet, so look it up, otherwise process it. And then if you already processed it, create a tree for it. So that's the base of this dissector. So, and I wrote this in the wrong file. Damn it. I'm sorry. So this is a dissector. This is in the root folder. This is what what it will look for. So utils. I will need a few utilities for all of this. So first off, utils. Just look up from here. To make these modular, so we can import them, we have to create these objects. So for example, here it's called utils, and then utils gets subfunctions, which I can call later. And at the end, I have to return this. Okay, so. Same with our Blaze global object. Okay. For example, I want to have access to the utils. As you can see, without the file ending, it will always assume Lua as a file ending. So now we could use blaze.utils, for example, to access any function in here. So, and I will also copy this, because the first thing before we can do anything is essentially being able to do log outputs. I know it comes with a log console for Lua code, but for debugging purposes it's not helping very much. So in this case I just write my own. And I need this. This is just a default folder I have on my hard drive here. You don't have to include this, but for debugging purposes initially this will help a lot. So we have Blaze print, and util is not doing anything yet. We have this, and it would be nice to try out the print function. So Blaze, which we have a reference up here. Print. Sorry. Dissector called. I'm not sure, but I think I have to make a new line as well here. And now let's just test this. So close Wireshark. I just let it load. And if I already made any errors, I will get an error message already. Okay. So what do we need? Relight Blaze lure, right? What? Relight, yeah. Okay, so you see it's already trying to access our code. Load it. Proto. Okay, so the name doesn't matter. I'm sorry about that. Wait a minute. What is proto? Fields. Ah, okay, yeah. I forgot a field, a step. We have to call our protocol. Okay. Let's do it like here. New file. Place. This is where we'll put all the constants. Okay. So then we need proto Blaze call for battlefield loop. Okay. So makes this globally accessible. Then use it in our dissector. Our proto object gets a dissector function, that's why the name is important, and we put this there. Okay. So much for that. Okay, nice. Okay, nothing to see yet. But let's see if we maybe already got output. I'm sorry, on fire. Almost. Okay, I don't need a new line, but we have been called. That is nice. So that works. Dissector called. Okay. So processed packets. Okay, we want to keep track of packets from Wireshark that we have already processed. So I do the same here. And then I think I use the util function, yeah. it's a bit I mean, this could be inlined everything, but I just like to go on a sure path. I don't know, I'm used to this. And okay. We need utils. Blaze has utils, okay. Blaze process packets. So packet number is something we get from. Yeah, I can change stuff about the packet info. So I can say this is now a Blaze packet. I get the number, so this is the number on the left of the packet globally. And then we would look it up. We want to process it. There's a few things I want to do here. So then we would create a root node. Yeah, we could probably already do that. And we want to add this packet number. For now, just empty object. But so we should see that we are processing packets and later just looking them up. And this protocol root. This is a node we can use later, but we will add it to the tree. And that's it. Okay. Let's try that for now. Okay, now it shows Blaze here. Oh, I can have uppercase. Okay, this also looks good. Processing, looking up. Okay, nice. So the first packet we process is number 4, and now we have our node that Blaze protocol data is supposed to be here. Okay, that is great. Yeah, every time I look up a packet in here, if I click on it, it will be looked up again. So, or the sector is called again. Okay, packet. So we want to create the packet, but first we have to create an abstract object to hold our data for the packet. Okay, another thing. So for the first packet, we obviously want to read here a few bytes, there a few bytes, there a few bytes. So take this byte array and read bits from it, and then process it. I have used for this an external library which is called Trigger, which will help me a lot in this case. Oh, I can even show his Git. Beyond bytes. Okay, thank you for this very useful library that I will use here. And all copy paste. So yes, I already need that here. That goes here, trigger. And first we take the byte array from the buffer that of the packet we want to process. Then we make a stream out of it, so my helper library can give me an object that I can read bits from. And yeah, that's probably good to tell at the end too, if we get stuck somewhere or not. Processing, and now we need essentially a module that processes our packets one by one. So file Blaze packet handler Lua. So this is very complex, but we just have to do simple stuff. So packet handler, then we need to make this available globally. Packet handler. So we want to have a function to read a packet, which takes our global object, a stream, and we don't even need to know if this is a server packet. And okay. Okay. Now we want to use this here. Oh, it also gives something back. So this is a packet. Currently nothing in it. And we just return it. So now we can have packet handler. Okay, and then done. So we have saved the packet. Okay, when we are processing them, we are not making a tree for it, so we don't get a packet back. We could in theory just we could still make a tree here at this part. So even if you're not showing it, why not make a tree? So if we already have the packet, we just look it up. Otherwise, we take it from here. Okay. So, and finally, we should make the tree object for it. Okay, let's make a break here and test if I have made any errors so far. Okay. Relight, yeah, okay. Blaze. You are called Blaze now. Okay. wasn't able to find the module. Nothing more? Okay. Okay. Processing, looking up. Okay. So that works. And I already want to make the class or module for the tree maker. So we haven't even read anything from the packet yet, but yeah. Bunch, tree. Okay, we need something like this. Global object or buffer or packet and the root node. As all fields need range, that is, if I click something in here, like this for example, it highlights a bunch of bytes. I could make use of that here. Not sure if I want to, because this is always byte aligned. And right, we need fields. The first field we obviously need is a header node that says here's the header node, and then it has subnodes with payload size and all the other stuff on it. So let's make the payload node first. We need to define it. So fields. We need fields, a lot of fields. This is where they all will be registered, and here is where they are defined. It's a bit confusing, but it will clear up in a minute. So where's my payload example? Payload, okay, let me take this. Okay, so in order for Wireshark to know how to display our fields, it needs to know what types they are of. So some could be a string, some could be a number, and depending on that, how it's displayed here, one of these nodes, I need to define first. Also, each of these fields, depending on the structure, have a name essentially that I could access up here to, I don't know, filter packets by that. I also don't like that this is still called Blaze. Where do I define that again? Protocol Blaze. Okay, so we have a field with the name payload. With a path payload, sorry, and the name payload. And that's it. We don't have to define more here because it's an empty field. It's just showing payload. This is instead, well, I mean, we will need this later. We also need a header field. Header. And now we just need to let Wireshark know that these exist. So that's why I register them here. So we have const fields header payload. Okay. So this goes into the proto. Well, maybe put this together. So again, here's definition, here's the registering. So our tree maker can just add them because they are empty. So here we have our defined fields, and of this we want to add a field of the type header. So like this. And we add this to the root of our protocol nodes that we get here. Let's open a Blaze packet. This is the root. Okay, and we also want to add payload later. Payload, okay. Let's see if I made a mistake. Doesn't seem like. But I do not get... Ah yeah, I have to also call it. Great that we created it, we haven't called it yet. So, packet. So, tree maker, did I register that yet? No. Tree maker. Packet, root. And only if we have a packet. Packet, not nil. Okay, now it should create nodes. Okay, we have a header and a payload node. Okay, let's look back at the header. So the header has just a few pretty static components and only one optional one. So we have to define a field for each of them, so to display in Wireshark. So let's take an example from here. I want to display stuff in hex usually, so that is already good, and I can say how wide the field is. Do we have UN16 somewhere? Okay, it doesn't matter because it's just a placeholder for the data later. So what is the first thing we need? It's payload size. Okay. Let's take one of these and get them over here. So from the header we have payload size. Well, lower. That's the lower part of it because it's. Well, let's just keep it as payload size for now. It has a value type, in this case uint, even if it's it will only use 16-bit of it. Payload must all be lowercase, I think. Payload size, and you want based in hex. Okay, and I have to register it. Okay. First off, we have to read this and put this in our packet. So first start with the packet handler. We have this stream here, and this can just read values for us. Let's see how that works. So stream read bit array. Read bit array is if I want to have a byte array out of it. I just want to have an actual number. Let's see this for example. So it's very simple. I just define this in the packet. Packet payload size plus stream read 16 bits. I'm not sure yet if the NDNS is right, but I can still write something for this later. And while I'm at it, I can add the other fields as well. Component command. Error code message type. Code message type. Only 8-bit. So then we have header flags. That is only 4-bit. And the message ID. That is 20 bits. So with the 4 bits from before, these together are 24 bits, which is divisible by 8 again. So the extra payload size. Let's have a look at already existing code, how they read it from their buffers. So if the header flags, which is byte 9, so let's see, byte 9, which is for example this one, can have in the upper part, so in the left 0, a 1, and if that's true, then it's extended. So our logic, if header flags and 1. So here it's the upper part. I only have these 4 bits, so I can just AND with 1, but I'm not quite sure about Lua and bitwise operation, so let me quickly look that up. Bitwise, and yeah, it's already great. Whoa, okay, wait, what? Why you have no bitwise operations? Okay, so I can do this natively. Okay. This and 1. Equal 1. Then read more, payload size, call it extended. And that's all we have to do to read the header into an object that we can later display the tree for. Okay, let's go to our tree maker. Here we have the packet again, and let's add the payload size fields that we already discussed about or created. Good example here. the reader. Yeah, something like this. So this gets added to our header. So we add a field there. The field name is payload size. The range that are from our buffer, we could actually define them here because we know them. So byte 0 to, is this inclusive or exclusive? I'm not sure. Let's see. And payload size. Okay. Let's see what Wireshark does with it. Can read the code, that's fine already. E500. Okay, that is definitely the wrong order. Okay, let's make a helper function then. Nothing like utils. Utils swap 16-bit. Actually, I can swap the whole 32-bit, just ignore it that it's a 16-bit value. Can I do that? Ah, better not. Value. Value. Oh, can I just write like this hex? Okay, that is fine. I don't know, you can never have enough brackets, just in case. Okay, so we need utils here. And then apply this here. Here and here and here, at least. For 8-bit it doesn't matter. So for the 4 bits and the 20 bits it would matter, but yeah, let's explore that later. Let's just fix that first. E5, okay, that's correct. So let's add the other fields. How does this look now? Still fine? Okay. Whew. Const. So now we need more of these. Component, command, error, code. Yeah, and then we already have header flags. Let's not go that far yet. So component command error code. Oh, we can also make a message type. Yep. So then we register them 1, 2, 3, 4. Okay, we already read them in our handler, so let's just add them here. So let's see if these ranges actually work. I haven't tested that. Looks fine to me. First argument is nil. Okay, so I probably have renamed stuff here. Payload size, component, common. Okay, what was it actually? Yeah, debugging this isn't fun. Line 11. 11. Oh. I removed this field. That's not good. This comes later. Okay. Let's try that again. Okay. And can highlight me the bytes in here for each of the fields. Okay, so well, I'm already 1 hour in. I guess I will make a part 2 to finish this header thing, but I hope you get the idea of how to create a protocol now. So you have to process the data, then write that into some abstract structure you can look up later, and from that structure you can create the actual tree nodes. This can be nested as much as you want. I will probably make a part 2 where I add the rest of the header and then start the payload fields, and also add the coding for these two, because these can be looked up. For example, the components. Well, where we have the definitions here. Yeah, they have names. So component 9 would have been util, for example. These are the different components, and each component has its own commands. that have to do stuff. We don't have to deal with that because we just want to display, and so we just need the names of them. Actually, let me see if I find that other definition file again. Message type. Here we have the message type, so client, server, notification or error. The packet that we just decoded essentially. And where are the function names? Give me a second. Commands. But no, there must be an overview. Oh yeah, like this. So the command ID depending. Oh wait, we had UTIS. Let's actually see which one this is. We have command number 11. Pre-out. Okay, it's the first packet. It makes sense that it calls the function pre-out. And then it will have a few payload fields with data needed for that. And yeah, we can display this data in here. Okay. Thank you for watching. If you have any questions, please write them in the comments, and see you soon. Bye.